Welcome to Module 3, Lesson 21, More Surface Area. Actually, it is not Lesson 21. This is Lesson 22. How can I mess that up? Lesson 22, More Surface Area. There we are. Okay. All right, let's get right into this opening exercise here. Okay, so our opening exercise here is going to work with this composite figure. Okay, in the well, actually, this diagram here isn't necessarily the composite figure itself, but it is actually the net of a three-dimensional image. Okay, this composite shape, if you remember, was the combination of two three-dimensional shapes. Okay, in this case we have this composite figure, which is a combination of 3D shapes. So the figure here that is going to be created from this net here. The question here is this thing a net for a three-dimensional image? Okay. Now, if you want to prove that to yourself or for yourself or by yourself, okay, you can find this composite figure at the grade 7 math website where the lesson 22 video will go. So this lesson, where this lesson video is going to go, right above it there will be a file you can click on that is a smaller image of this, and it'll create a 8.5 by 11 sheet, which you can go ahead and print out if you'd like to prove it to yourself, or decide then whether or not it is a diagram for a net for a three-dimensional image. Okay. So in essence, what we have here, or we have all of these 18 squares. Okay, we have 18 squares right here. Now it's nice we know these are squares because they are 2 by 2 units, because we can, and I'm just using the I'm using this graph paper here. Okay, as you can see, each one of these is 1 unit. Okay, so they go across 2 units, and 2 units that way as well. Okay, so that's where I'm getting the 2 by 2. So we have 18 of these squares. When we flatten it out as a web, sorry, not a web, as a net, we can do this more easily, especially when all of these are the same shape. Okay, and they're all squares. Okay, so we have 18 of those, and each of those, as I mentioned, are 4 square units in area. Okay, and that equals 72 square units. So this entire three-dimensional, well, actually not three-dimensional, but this two-dimensional net here has a surface area of 72 square units. Okay. Now again, back to that question, is the diagram a net for a three-dimensional image? Now you can go ahead and do the folds in your head, just imagining it, but one thing you need to just pay attention to is all of these, the little jagged or the dotted lines. Those are all your fold lines. Okay, and again, you can do it here, and maybe I'll give you a little time to think about it, consider it. But if you imagine, for example, this is going to fold down, that's going to fold down, this whole thing right here is going to fold down. This thing in mass is going to stay this shape, as you can see, but it's going to fold that way. Okay, so you can get the idea of the things that are going to happen in this if you want to imagine it, okay? But if you don't want to imagine it, and if you don't feel like cutting it out and folding it up, though I must say I had a great deal of fun doing it. If you're going to do it, do it. Maybe print it on some cardstock or some index stock paper. It's a little bit sturdier, okay? But it's kind of fun if that's something you like to do. But I'm sure you have lots of other more important things to do. But anyway, yes, if you did cut this out and make all the folds where the dotted lines are, you would indeed have come up with this three-dimensional shape. Alrighty then, let's move on. Here we go. We have a pyramid. All right, we're going to talk a bit about pyramids today. There'll be a lot more on pyramids in Module 6, and that's with all the geometry, and that's at the very end. And hopefully, those of you who are on pace right now, staying on track, will actually get all the way through that geometry. I don't think, well, I'm sure not all of us will, but if you can, maybe work into the summer and work on that. It's be a good place to start the next year, 8th grade, having some basis in that. Okay, but again, pyramids will be covered much more later on. For now, we'll just use them in terms of surface area. Okay. Now, the one thing about this pyramid that is very important, because we're going to try to find the surface area of this pyramid, is that this pyramid in the picture is mentioned here has a square base, which means that it's going to have 4 lateral faces coming off of it. Okay, and there is one of those lateral faces, and there would be another, and then another, and another. Okay, and you can imagine that, and you can see that because it makes sense, because each one of those is attached to this square. All right, and if there are 4 sides to a square, there must be 4 lateral faces. Okay, and now remember the area formula of a triangle, again, just to reiterate, is 1/2 base times height. Okay, because our goal right now is to find the surface area of this pyramid. Okay, therefore, if we have our formula 1/2 base times height, our lateral area, remember the LA stands for the lateral area, and that does not include the bases or base. Okay, in this case we have only one base on this pyramid. Okay, but therefore now our LA, our lateral area, is equal to 4. Okay, 4 different lateral faces that 1/2 base times height. It is a square. Okay, which makes it possible, or it makes it possible for us to just find one area of the triangle and then multiply it by 4, because they're all going to be identical. Okay, and then we also have a square base, so we know our base is a square. Okay, and therefore our base is going to equal side squared. Okay, and each of those are 6 centimeters, as you can see. Okay, so we have 2 things to find out. We actually have 5 faces that are going to help us out. 5 total faces, which are the 4 lateral faces, and then the base, one base. Okay, let's go ahead and figure this one out. If we plug in all the numbers, the lateral area is 4 1/2 base times height. We have a base and a height of 6 and 7, and then together 1/2 of 6 times 7, which is 42. 1/2 of 42 is 21, and then we multiply that 4 times. So the total lateral area, the area of the lateral faces, is 84 centimeters squared. Okay, and then with our base, very simply, 6 squared. 6 squared is 36, so 36 centimeters squared is the surface area of our base. And if we go ahead, the surface area, SA, is surface area, and that refers to total total surface area is the lateral area, lateral faces plus the area of the bases, and that is 84 plus 36, which equals 120 square centimeters for the entire surface area of that square-based pyramid. Okay? And again, taking it apart bit by bit, I'm not sure there's much in this lesson for you to do alone. It's pretty much all guided stuff. But when you get to the problem sets, you will get some chances to do it by yourself. But again, taking it apart bit by bit, when you work with these three-dimensional shapes, especially something like this pyramid, you're going to need to take it apart. Lateral faces, do everything that you can that has something in common. All four of these lateral faces were similar because they came off of a square, so that made it handy. So take any shortcut you can. Okay, and there you can see the surface area of the pyramid is 120 square centimeters. Okay. Now, using cube, all right? So I'll read this here, there are 13 cubes glued together, forming the solid in the diagram. The edges of each cube are 1/4 inch in length. Find the surface area of the solid, and that's what we'll get to towards the end. But one point, this activity would be much better if you had cubes to work with. So if you have cubes to work with, and many of you may, you might have a younger sibling or even yourself have a kit, a math manipulatives kit, which has some of those maybe interlocking cubes or just the small colored centimeter cubes. You could use those as well, or anything else you may find around the house that would work, and are all equal or identical cubes. Okay, be really nice to be able to go ahead and make this shape or make this three-dimensional solid here. Very good, especially because you'll be able to flip it over. I can't flip it over here on this two-dimensional page. All right, but yeah, if you do have them, go ahead and grab some cubes and actually make this. Put these 13 cubes together in this fashion. Okay, yeah, and these cubes are glued together, which is really important. I mean, if we know that a cube has six faces, okay, and then maybe you might want to say, well, okay, 13 cubes, 6 faces, that's 78 total faces. It's not going to work that way because they're glued together. So every one of these cubes is losing at least one of its faces by being glued to another cube, or actually, in a sense, that bottom, the second level, the lower level here of cubes, actually loses quite a few of its faces. Actually, a couple of them, actually 1, 2, 3, I think 4 in particular, lose how many? 1, 2, 3 of their 1, 2, 3, 4 of their faces to their or 3 of their faces by being glued together. Okay. All right, so the edges of each cube, it's just something important here because we're going to try to find the surface area. We need to know that each one of these sides or edges of each cube is a 1/4 or 1/4 of an inch in length. Okay, and then that's our aim, is to find the surface area of the solid. Okay, so let's go ahead and we're going to take it apart. I wanted to look at it from top to bottom. So first I'm going to look at those 4 cubes on top, okay, those 4 right there. And now 5 of these faces are exposed because when we talk about surface area, the idea is that, let's say I'm going to paint this this solid, this figure right here. If I'm going to paint it, I want to know exactly how much paint I'll need. Okay, so I want to know in this case it's going to be inches, square inches. I would need to know because I need to cover that much area. Okay, so anything that's exposed that can actually be have paint swathed on it, okay, matters. All right. So each of the 4 cubes have 5 faces exposed. Okay, so let's just keep track of faces right now, because we can count up these faces and we know they're all the same area, because they are all cubes and they're all made up of square faces. Okay, so we have 20 faces right now. Okay, so also on top there are another 5 exposed faces. Now those are the cubes from the bottom row. Okay, and they're facing up. That's the tops of those. Okay, so you can see those right there. Another 5. Okay, add those 5 over there. All right, along the outside of the bottom level. Okay, outside the bottom level, boom, you can see we have another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Another 12 faces. Okay, another 12 faces. Add those. All right, and then finally the bottom. Okay, so like I said, if you have actually put this together with some linking cubes, you can flip it over and you can very easily see the exposed faces on the bottom. But I know that it's a 3 by 3 construction, so I know that 3 times 3 equals 9, so another 9 faces. Okay, so if we add all of these up, 20 and 5 is 25, plus 12 is 37, plus 9 is 46, so we have 46 faces. Okay, so that's my first step. I have 46 faces exposed. All right, get rid of all that, and let's put our 46 faces. So we are going to actually multiply these 46 faces by the area of one of those faces, because they're all the same. Okay, and there we go. We have a 1/4 inch by 1/4 inch face. So we're going to multiply 46, which is the number of faces, times 1/4 squared. Okay, because that's how we're going to find the area of each face. 1/4 times 1/4, which is 1/4 squared. And when you do square 1/4, you get 1/16, multiplying it by itself. So now we're going to multiply 46 times 1/16, which is the same as 46. Blah, 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 blah. Okay, and you can see I've gone and gotten it down to the simplest form. And in its simplest form, we have 2 7/8 square inches. Okay, and that is the surface area of the solid. All right, very, very simple when you're talking about cubes. Could not be simpler. Okay, find your exposed faces, find the area of one of those faces, and then multiply. Okay, just one of those strategies that will help you get by and complete something that at first may look absolutely overwhelming. Okay, but it doesn't need to be. So, how are the methods of finding the surface area of a pyramid and prism similar? You can remember last lesson 21, we talked a lot about right prisms. If you remember, right rectangular prism, what we had a right rectangular or triangular prism, right pentagonal prism. If you remember that, how are the methods of finding the surface area of a pyramid and prism? And those are the two things just want to talk about just real briefly, just in between here. Well, in both cases, we find the area of each face, including base or bases, and add these together, okay? And that's what we keep doing. You know, we are doing this throughout. We are finding the area of each face, including the base or bases. Everything could be called a face, okay? The base just changes from shape to shape, and different designations, okay? But that's how they're similar. I mean, that's the whole basis behind finding surface area. So you're trying to find all the area that can be, like I said, painted, washed, wallpapered, okay? Because you can't paint or wallpaper or wash, in that that shape we just saw, you can't do it to the faces that are being hidden or have been glued together. You just can't. It's no longer surface, okay? They've lost that surface area by gluing those together, okay? Now the question is, how are the methods of finding the surface area of a pyramid and prism, not similar, but different this time? How are they different? Okay, think about a pyramid and a prism. Well, the shapes of the faces make it different, okay? That is the shape and shape only. If you remember with a prism, we had a prism's faces, actually should be faces if you remember. The prism's faces are all rectangles, and they have two bases, okay? If you can just imagine, or if you want to go back and look at lesson 21 again, I could have put a picture here, but I didn't. If you go back there, you can see a picture of the prism. You know, they have the two bases. Let's say the pentagonal prism, if you remember, two pentagons for the bases, and then all the other faces, the lateral faces, are rectangles. Okay, so in a prism, pyramid, on the other hand, okay, a pyramid's faces are all triangles, and it has only one base. Okay. That base does not have to be a triangle, okay, but all of the lateral faces are going to be triangles because we know a pyramid ends up coming to a point, and the way it comes to a point at the top is because it is made up of triangles, okay, and it has only one base. And just think of one of the great pyramids in the desert, okay, in Egypt and elsewhere. But yeah, only one base, but that base does not necessarily have to be a triangle. It could be a square, it could be a rectangle, and we'll see as we go along. Actually, I think pretty soon we will see, but not quite yet. Okay. Alrighty, so here we go. We are going to eventually find the total surface area of this wooden jewelry box. Okay, now I'm looking at this jewelry box a little bit differently than the people who put this together, because I thought something in the solution, didn't look right to me. So I'm going to change it up a little. I don't think it'll matter to you because you don't have any extra directions outside of these that are right here. Okay. But first of all, before we go ahead and find the total area of this wooden jewelry box, okay, which, by the way, we'll talk about it again later, but if you'll notice here, they tell you that the sides and the bottom of the box are all 1/4 of an inch thick. And you can see, so right here, this is going to be a 1/4 inch thick piece of wood, okay, a piece of wood that just goes down this way. You know, that's a 1/4 inch. It's not just it's not just a piece of, it's not paper thin, okay? It actually has some depth to it. And they want you to know, and this is actually very realistic, when you use something like this, or you build something like this, I mean, you're using wood that has some actual depth, that has some thickness, okay? And that's going to make a big difference, because you're going to see we're not only going to, in this case, we're not only going to measure surface area of the outside of this box, but also the interior of this box, okay? Let's say we want to just paint the inside as well, okay? Let me get rid of this. This is probably getting in the way. Okay. Alrighty, yeah, so, but first let's ask this question. What are the faces that make up this box? All of the faces that make up this box, okay? So we have this face, which is that bottom. We'll call it a base, really. It's that one, that 6x10 face or base, and then we have the top one. Now, in this example, it doesn't look like it here, but I am going to say that this jewelry box, wooden jewelry box, has a top, okay? Right now, let's just say we've removed it, okay? We've removed the top, okay? But it does have a top, okay? So that means that's another face. And this is where the directions were kind of weird, so I added that on there. Okay, we also have another face. This face over here, we have a face we have another two faces actually. This 10 by 4 face here, and then we have its partner or companion 10 by 4 face in the back, which we can't really see real well. And then another two faces. Okay, this 6 by 4, two 6 by 4 faces. All right. So there we go. So we have, what do we have there? We have 1, 2, 3. Actually, and then we have the inner lateral faces as well. Okay, so and there's one right there. You can see that side. You can see that inside lateral face there, an inside lateral face there, one there, and one at the bottom. Okay, yes, that's that bottom, and that's the bottom that's inside. So if you put some jewelry inside of this jewelry box, you'd be putting it on that face. Okay, that face right there, that last one that was in there. Okay, and then under the top when the lid is on. Okay, so the lid is off right now, but we're counting the top of it, okay, as being part of the surface area, the lid, and then we're counting the bottom of that lid as well. So we're going to do this when it is on, okay? All right. So before we start doing any calculations, another question. So how does this box compare to other objects that you have found the surface area of? What is similar or different about this one? Well, the box is a rectangular prism with a smaller rectangular prism removed from its inside. Okay, so everything that we've looked at so far and everything that we've actually done, any measurements and figuring surface area, all of those were solid figures, were solid shapes, which means there was no inside. Okay, well, we're assuming, of course, there was no inside. They were solid. Okay, now this wooden jewelry box, like any box, is not solid. Okay, because a box can't be completely solid because it wouldn't be a box. Okay, but in this case, it's in any box truly is a prism of some sort, and it's had its insides moved, taking a smaller rectangular prism and removing it. Okay, and then the total surface area will include the SA, or the surface area of the larger rectangle faces plus the lateral faces and bases on the inside. Okay, so when we're talking about a box and we're talking about surface area, we are no longer, unless we specify just the outside, but in this case, we are not looking at just the surface area of the outside of this figure, but also the inside faces as well. Because again, maybe I want to wallpaper or paint or color with a marker every face in this box. Okay, I want to design it. Where are all the places I could actually paint? And they are all there. They're outside, inside, bottom, top. They're all part of what we think of as the surface. Okay, so some questions. Now let's go ahead and start calculating. What we're going to look at, we are going to look at first the large prism. Okay, the larger prism, and all of its measurements. Okay, and its calculations. And if you want to, I mean, I highly recommend that you try this yourself. So I'll just tell you right now what I'm going to do. I'm going to go ahead and take all the measurements of the large prism. I'm going to come up with a total SA, total surface area of the large prism. I'm going to do the same with the small prism, and then I'm going to add those together to come up with the total surface area of the box. Okay, and again, remember, include the top of the jewelry box in your surface area calculations. Okay, so if you want to go ahead and do that, I highly encourage you to do that. Give it a whirl. Come on back, check it with me, and see how you did. And please just pay attention to the fact that these sides are all these faces are 1/4 of an inch thick. Okay, and that's going to do something to your measurements when it comes time to make your internal measurements. Okay, but go ahead and give it a whirl. Okay, for those of you who stood here, or those of you who are returning, here we go. Let's do this together. Okay, so SA, that's surface area. That's the total. The surface area is the and we'll talk about this large prism now. The surface area calculation is going to be the LA, or the, again, lateral area. Those are all the faces, the lateral faces, moving up, going up and down, of course, and plus the two bases, okay, the two base calculations. And we are using two bases in this large prism because I've decided to include the top of the jewelry box, okay? All right, so, and here's our calculation. We'll take this apart one at a time. We'll do one part at a time. But first, let's talk about the lateral area. And remember, from lesson 21, the lateral area was perimeter times height. Remember, we find that perimeter, the measurement around the bottom, or around the base, okay, and then we multiply that by the height, right? And in this case, that perimeter of the bottom is 32 inches. Okay, let's go take a look at that. If you see, the perimeter here is 32 inches because we have 6 inches here, plus another 6 there, that's 12, plus 10, 22, and another 10, 32. Okay, so there is our perimeter measurement right there. Okay, so wow, that was weird. Holy moly. Okay, let's do this. Get back to where I was. Okay, so yeah, 32 times 4, and that equals 128 square inches. All right, so the lateral area of that large prism, very simply, we calculated this as 128 square inches. All right, now the base is very simply length times width. Okay, and that's the base, and as we saw, we just looked at it, it was 10 by 6, and 10 times 6, of course, is 60 square inches. All right, so that is our base measurement. We have two bases, okay, so our total measurement of our bases, or total surface area of our bases together, is 120 square inches. All right, ignore that one. And we add these two together. We add the lateral area and the base area, and we get 248 square inches. Okay, and that would have been the easier calculations to do because there was no thickness to worry about. Okay, the outside, we didn't need to pay attention at all to the thickness of the wood that we used. Okay. All right, so let's go ahead and look at the smaller prism, and that smaller prism is actually the hollowed out prism inside of this larger prism. Okay, and again, we're looking at surface area as being the lateral area plus the two bases. Okay, again, lateral area equals perimeter times height, and here's where it gets a little teeny bit tricky. Or let's find out the perimeter. It was really easy to find the perimeter of the large prism, but in this case a little bit trickier because the perimeter here. Let me just go back and look at it. You can see the perimeter is now of this of the inside of this box. Okay, is not going to be that outside line, but it's going to be this line in here, which actually is 1/4 of an inch on either side shorter than the outside perimeter. Okay, the perimeter that was out here. Okay, it's 1/4 of an inch on each side more narrow. Okay, so if we take a fourth of an inch on one side and another fourth of an inch, we're looking at a half of an inch. We have to make an adjustment of half an inch on both sides, and so that, I mean, total, half inch total. Okay, so let's go back and see. I hope I can do this right. Let's get back to where we were. Okay, so there we go. So now instead of a 10 by 6, as we saw over here, okay, as the base there, well, that said base is also perimeter there, okay, was 10 times 6. It's actually now 9.5 by 5.5, so they're a half an inch shy, both of those, all right? And then we're going to multiply that by 2 because it's a, we have that all the way around. It's a square, so we have it all the way around. And there 2 times 15, because 9.5 plus 5.5 is 15. 2 times 15 is 30, so our perimeter is 30. So I did a little extra step here. Perimeter I just very simply found over here was 32. Was 32. Okay, it was 32 was the perimeter of the bigger box. Okay, but instead of using the 10 and the 6, I used the 9.5 and the 5.5 because of the wall thickness. Okay. All right. So now the height is 3.5. Again, it's not 4. Okay, as it was over here because I lose a fourth of an inch again on both sides. So it's 3.5. Okay. So if I go ahead and find out my LA or my lateral area, I'm going to do 30 times P times H, which is 30 times 3.5, which is 30 over 1 times 7 over 2, which equals 210 over 2, which is 105 square inches. All right, 105 square inches. So now I very quickly am doing the base. Sorry, that went really fast. But again, if I'm going to do my base, I know what my base is here. I'm going to do 2 of them. Okay, because I want to account for the underside of the lid as well, okay, as well as the floor, okay, which is the other base. Again, 9.5 and 5.5, of course, come from, are the same as these up here, because those are my dimensions now, because I've lost that the fourth of an inch on each side because of thickness, okay. So yeah, I just go ahead and go through, and then just change those mixed numbers to improper fractions, and do all my multiplication through, and I end up with 104 1/2 square inches. Okay, so now I have 104 1/2 square inches, and then 105 square inches. Put that together, that's 209.5 square inches, and then my final surface area of the box, inside and out, 457.5 square inches. So if you did do this yourself, I hope you came at least kind of close. If your process was good, maybe a couple number slip-ups here and there, who knows, maybe I slipped up. That's fine, because I'm really, really interested in you getting to know this process and know this process well. Whew. I know I kind of rushed through it. It took me a lot longer to put that together before I actually did the recording, but that was a lot of work, okay? Calculating surface area takes time and patience, and takes a lot of care, because it's easy enough to make a mistake, especially when you're dealing with fractional values, okay? Now, some strategies like making nets, adding the area of faces, counting square faces and multiplying by the area. Okay, we've done all of these things throughout this lesson. So those are all to make your life a lot easier. So please, 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 please take time to use some strategies. Okay, piece at a time. You're going to find the area of a bunch of cubes all stuck together in any which way. I mean, it'd be a lot of fun. We can do that in class. It might be a great activity to do. But if we did pile them up I mean, what do? You got cubes, all the face areas are the same. Find one face area, and then go ahead and just add up your faces, do your multiplication, and you're done. Okay? So yeah, I mean, it doesn't need to be the hardest thing in the world, but again, very often it's going to take a lot of time. So if you would go ahead now and take some time, this wasn't so bad, only 40 minutes compared to 21, whew, which is another big whew. Yeah, go ahead and take some time on doing your problem sets, your exit ticket, and good luck, and see you soon.